Hello class. In this video I'm going to explain the basic concept of informal proofs, and I'm also going to try to convey to you the skill that you're going to need to master, which is how to give an informal proof. We'll do this by looking at exercise 2.5 of the textbook. You don't have to do this problem for problem set number 2 yourselves. This video is just covering one of the fundamental skills of the course. So in 2.5 what you're supposed to do is prove the transitivity of identity. Transitivity principles are principles that say things like A equals B and B equals C, therefore you can cut out the middle term of the middleman B and conclude that A equals C. Usually these principles are explained with the premises in the reverse order so that you can read it top to bottom and clearly see that B is the middleman that you can cut out. But nonetheless, the premises just as much entail the conclusion in this form. So how do we prove such a thing? Remember, proofs are step-by-step demonstrations that an argument is valid or invalid, but in this case the argument actually is valid, so we're going to prove as much. Now, what are the steps in the step-by-step demonstration that you're allowed to do? Well, sometimes we're going to specify the kind of steps that count as allowable baby steps, and that's what the book does here by saying that you're only allowed to use the indiscernibility of identicals. That is the only baby step which you're allowed to use, and that's all that you need in order to get this proof to work. So what is such a principle? Let's just scroll up to where this is explained in the book, and we'll see. If you go up a couple of pages, you'll see that there's a summary of this indiscernibility principle here. Identity elim is the formal proof rule that's the analog of the indiscernibility of identicals. Really, those are two different names for the same thing. Identity elim is the way it's referenced in formal proofs, and indiscernibility of identicals, or II, is the way it's referenced in informal proofs. So what do these principles say? They basically say if B and C are the same object, so if B does indeed equal C, those are just two names for one thing, then anything that's true of B must be true of C, because after all, B and C is C. Why is it called indiscernibility? Well, you can't distinguish between B and C. You can't discern between them if they are one and the same thing. You can't discern between one thing and itself. So let's say B has some property like property P. Well, then C must also have property P. So whatever properties hold of B must also hold of C. After all, they're one and the same thing. Okay, so how do we appeal to such a principle? In proofs, what that means you can do is, anytime you have an identity sentence, you're allowed to trade on that identity by substituting one of those names in for the other. So you can read this as, wherever I have a B, I'm allowed to put a C. I'm also going to allow you to read it equally well in the reverse direction. Anywhere you have a C, you're allowed to put a B. That's totally legitimate too. Okay, so how do we appeal to that principle in giving an informal proof? Well, remember, proofs are explanations or demonstrations that the argument is valid, so we're going to have to pull up a Word document and give such an explanation or demonstration. Since this is an informal proof, we're going to have to do it in English. So I'm just going to write exercise 2.5. Now here's what my answer would look like if I had to do this for an actual problem set. First, I need to look at my premises and reference them. So I'm going to just say, by premise 1, we know that B is C, B and C are the same object, so whenever we have a B, we can put a C, or substitute a C, and that's just by II, the indiscernibility principle. Now in premise 2, now let's find the place where we have the B where we want to put a C. Well, that's the context second argument place of premise 2. So in premise 2, we know that A equals B, so we can put C in for B, that's by II again, and conclude A equals C, and then we're done. Notice what I did in this explanation. It's in English, so this is an informal proof. I referenced my premises and explained extremely clearly what kind of step-by-step procedure I'm going to accomplish in order to get to the conclusion. I referenced clearly where I was making this substitution by the indiscernibility principle, namely it's in the second argument place of premise number 2. Now this can be somewhat confusing because both of these predicates are identity symbols. So when I use the indiscernibility principle, I'm doing a substitution trading on an identity, but in this case actually the one I was trading on was premise 1, and I was using premise 2 as the destination place where I was going to insert my name C. Notice I actually could have done it in the reverse order, but my proof would have looked slightly different. I could have said, hey look, I know that A equals B, so anywhere I have an A I can put a B, or vice versa. Anywhere I have a B, I can put an A. Then I'm going to use the B up here as the destination, and I'm going to insert the A into that. That would be just as legitimate. There's more than one way to do a proof. Actually, There's always an infinite number of ways to do a proof, and we can prove that later on in the course. So there's not only one correct answer for any of these, but notice even though there's two different ways of doing it, even by the very same inference rule of the indiscernibility of identicals, it was extremely clear to the audience, the people reading my proof, which way I was doing it. You want this kind of clarity and transparency in all of your proofs. This is the kind of model answer to shoot for. Even though it's extremely short, the answer here, it's also extremely explicit and clear. Okay, hopefully that gives you a good sense of what an informal proof is, as well as conveys to you a little bit about what the skill is that you're going to need to master, which is giving clear informal proofs. Thanks.